Okay guys, in today's video we're going to be talking about ports on computers and other network devices. And I'm going to be using the post office analogy to start off with. In this picture here of a computer world, this is a representation of one single computer, and it's very important when you get into this world to realize that each one of these applications has a completely separate part within the computer's system, and they really have nothing to do with each other, and they are created by teams of other people that sometimes are even competitors, like Firefox and Microsoft Edge here. But all of these different applications doing their own things, they all have a common need to have messages come in and out to the rest of the world to their applications. And so they all need to share a common post office where their messages can be delivered and outgoing messages can be taken to. So in this computer world, the post office is represented by the NIC, the Network Interface Card. This is where all the applications need to come and to do their in and out, to get on the internet or the LAN or whatever your Ethernet section is connected to do its business. Now, the post office here doesn't really know, has no idea what's in the contents of the letters that come in and out of their facility here, and they could make no sense of what's inside the messages. Just like if a Google Earth message accidentally got stuck in a Telex box, Telex would have no idea what to do with that internal data because it doesn't have the same language set up to process that. So, but they all can share the same post office, and they can all share the same address system and wrap their messages in the same looking letters that are common to everyone, so that it's a very efficient system to get the messages in and out. Now, some of these messages, instead of going to any individual application, are for the system administrator, for the network in-house stuff. So it's got a separate box for it. But anyway, I just wanted to show you how all these different applications are existing simultaneously on your computer, and they're sharing this one common place. So let's take a look at the inside of the post office here. What you can see is that as the incoming packets arrive, they have to be sorted, and depending on what their address is, will determine whether, okay, this, let's say it's an ART command, it will not have a port assignment. It's going directly into the admin section of the NIC that handles those types of requests. Same with ping or IGMP or any of those kind of things that are kind of in-house post office related for the mother system. The rest of the packets, when they're sorted, they'll have to go to an individual port, so that the application that's expecting that information coming in can then retrieve it and take it back into their world and do whatever they're going to do with that information. But when the packets come in, if there is not an open port available, and otherwise there's been no application that said, hey, we want to get packets coming in on this destination, they'll they'll get thrown in the trash, and maybe they'll actually get a return reply saying, "Hey, you tried to send us this packet. We got the packet, but we could find no application to run it. So we're going to send this back to you, saying, thanks, but no thanks." So now, as soon as one of these packets come in and they go into an application, the application essentially gets notified right away, if you will. And this is complicated behind the scenes stuff as far as how it actually works. But I'm just using, these little gratuitous examples here to make the explanation. But once they go in, it's up to the application to do whatever they're going to do with that data. And same with the application says, well, I have a packet that I need to go out. They also have to come over to the NIC and essentially put it in the outgoing packet slot, where the NIC will then now send it out to the world, wherever that is, on the other side of their RJ45 cable there. So, but when it comes to the computer itself, and you're saying, okay, well, how about where can I find out where all the different ports are, or what ports are open and who's using them? All you have to do is come over, and we're going to bring up a command prompt. And on this command prompt, let me move it over here some. The command that you're going to use is netstat space -ANO. And what that command says is just show me all the open ports that are going on right now, all the things that are open being used by another program. Tell me what's where they're aimed at, and then on the far right here, this is the program ID. This is the program responsible for running the application, the port. So, for instance, let's take one here where you're seeing this computer here communicate with a bunch of different other IP addresses, and they're all using 4880 as their program. Now, to look up which program uses 4880, all you have to do is bring up Task Manager and go into Details, and you can select the PID, and what that does is it sorts all of them by PID, and we can scroll down here and we can find, 4880 is being controlled by Microsoft Edge. So that's how you can get ownership of each one of these open ports. And you can also scan down and say, well, hey, I was thinking about using port 1054. And you can just quickly look down the list here and see if there's anything that was coming close to that. And there's not. So you say, okay, that would be a free available port. And I'll show you here in a second, because we're going to transition to the Telex CSoft and WireShark, so that we can actually see these and see the ports as they going out on WireShark, and also we'll see where Telex will grab a spot in this list when we bring up the program. So, all right, we'll stand by for that, and we'll keep going. Okay, let's take a look at the ports in action. I have the CSoft program pulled up, and we're going to change frequencies and capture the packet of the frequency change going out, and we'll also get a enunciation response from the radio on the other end saying the word "to," and we'll see the packets coming back in that represent that word "to" in digital form. So let's just get going here with it. I'll change the frequency on the radio. See, we got the 2 coming back here. So that's what we're going to be doing in our little test. But let me show you first the we got the programming to make sure that those are the same. So if I go in and look at the IP223 programming here, I have the same receive multicast and transmit multicast addresses, and they match my Telex CSoft programming up here as well. And I got the 1054 receive port and the 1275 transmit port. And in Telex world, the receive port always refers to the audio coming out of a radio going toward a console, and the transmit port is always referring to audio going toward a transmitter to be sent out as RF. So you can see on our programming here we're matching, so we should see that 1054 and 1275. So if I come over here to my I bring up my WireShark program, and I'm going to select my Ethernet port and start capturing. So we're now listening for the Ethernet port. So I'm going to go back over here to my radio console, change it to 2. And we'll see that created a series of packets all the way to 158 here. So we're going to go ahead and stop capture. And if we go back up here and look, the very first 2 packets that we sent out were the address of the PC here of this laptop is .126, and the IP223 is .125. So the very first one that we sent out for the multicast address. Notice that we're not sending it to directly to 125, but the multicast. And you can see that over here in the destination that we have the 01005E to start our MAC address. So we know that that's what's coming after that is going to be a multicast. So and then you can see on the destination port and source port, they're the same, and we're sending this essentially bytes of data, this 15 bytes of data. So if you go and look, this is this 682 number here. This is the magic little series of numbers that the IP223 needed to see at the other end to tell it to change the frequency. And that's whatever machine language they're using there, but that was the trick to get that done. Now these all the rest of the packets here come in, and you see they're originating from .125, which is the IP223. They're using the port 1054, and when you look at their data bytes, this little data chunk here, you see this one's 92, going to be 92 bytes long, and that's the same for all of them here. So 92 is the information actually needed, and it took another 34 plus 8, so 42 bytes for all the overhead. But basically, they'll take this 2502 number and then add it up with the next one, then add it up with the next one, and add it up with the next one. And when they're all said and done, and they have all these numbers lined up like this, they'll run it through the codec processor, and out will come a human-sounding voice saying 2. So, and it takes, in this case, about 156 packets, it looks like, to make the word 2. So just goes to show you life's not easy for a computer. But this is this is showing it in action, and we can confirm if we look on our command prompt over here, and we pull up, and let's just go ahead and start it from fresh. I like showing some. We'll go CLS, we'll clear the screen, and we'll go the command to see everything is going to be netstat space dash ANO. And what command is going to do is it's going to list all the open ports that we have on the computer. And so each one of these at the 135, 445, these are all open ports. So if we scan down the list here and we're looking for our the two that we have, the 1054 and the 1275, you'll see they're over here, right here. And if you follow over to the program ID in charge of them, it's program 1076. So we can now go over to our task manager and go over to the details section, and we're going to sort our things by the number here, and you see it pulled it up right there because I was looking at it. But if you scroll down, you'll see 1076. Sure enough, that's CSoft runtime.exe. So we confirm that, okay, those are the ports we're using, and CSoft runtime is the executable program that's responsible for them. And it even shows you it's using 200, looks like 200 meg of memory to do its job. So, okay, this is like I said, this is just a kind of introduction to the whole ports thing. I hope it helps, and we'll talk to you soon.